In a cosmic twist, NASA's James Webb Space Telescope has found strong evidence of a gas giant exoplanet around Alpha Centauri A, our nearest sun-like neighbor just 4.3 light-years away. Alpha Centauri A is part of a triple-star system, and despite Proxima hosting 3 known planets, finding worlds around A had proven elusive. This candidate world is roughly Saturn mass and orbits about 1 to 2 times the Earth-Sun distance, placing it in the star's habitable zone, though as a gas giant it likely can't host life. Dubbed the disappearing planet, it appeared in Webb's August 2024 image, but vanished in follow-up shots taken in early 2025. Researchers modeled a highly elliptical orbit to explain this disappearance. At just 4.3 light-years distance, this candidate could be much easier to study than far-flung exoplanets. If confirmed, it would be the closest habitable zone planet ever directly imaged, potentially revolutionizing our search for nearby worlds. In a nearby stellar nursery, astronomers discovered a newborn world like a cosmic Pac-Man. The Very Large Telescope in Chile imaged a protoplanetary disk with multiple concentric rings around a young, sun-like star. Tucked in one of the gaps, they found a gas giant planet. This infant world, named Wispit 2b, is only about 5 million years old and roughly the size of Jupiter. It is actively gobbling up gas and dust as it carves a clear groove in the disk. Remarkably, Wispit 2b is the first confirmed planet ever seen embedded in a multi-ring disk of gas and dust. It literally formed within the ringed vinyl record around its star. It's also only the second very young giant planet found around a sun-like star. This 380 AU-wide system is an exceptional laboratory for studying how giant planets grow. In fact, Wispit 2b still glows in infrared from the heat of its formation. This rare system gives astronomers a real-time glimpse of planet formation. Last year, astronomers witnessed a flash so intense it nearly overwhelmed their detectors. On March 16, 2025, Canada's Chime Radio Telescope Array detected an ultra-bright fast radio burst from a galaxy only 130 million light-years away. This record-breaking burst, nicknamed RBFLOAT, outshone every other radio source in its galaxy for a few milliseconds. Until now, FRBs had mostly been found billions of light-years away, but RBFLOAT is the closest and brightest ever recorded. This gives scientists an unprecedented detailed look at these mysterious signals. Using newly added outrigger antennas across North America, researchers were able to pinpoint RBFLOAT's origin to the edge of a star-forming region in the galaxy NGC 4141. That precise localization is key. It suggests the burst came from an older magnetar just outside a stellar nursery. This milestone detection brings us closer to understanding the true origins of FRBs, one of astronomy's biggest mysteries. Could aliens already be hearing us? A new study finds that Earth's deep space communications are unintentionally broadcasting our presence into space. By analyzing 2 decades of NASA Deep Space Network transmissions to probes near Mars, the researchers discovered that signals often leak past their targets when planets align. Because Mars and other planets only partially block these beams, an extraterrestrial observer positioned along the Earth-Mars line could intercept our spillover. In fact, the team calculated that during an Earth-Mars alignment, there's a 77% chance an alien would be in the path of one of our signals. This insight suggests a new SETI strategy. Focus on exoplanetary systems during planetary transits, which mimic these alignments. Essentially, planets act like windows. When aligned just right, our broadcasts leak through, giving potential watchers across the galaxy a chance to detect Earth. Peering at our sun with unprecedented clarity, astronomers captured the smallest solar flare loops ever seen. during an X-1.3 class solar flare observed on Aug 8, 2024. The NSF's Daniel K. Inouye Solar Telescope recorded dark thread-like coronal loops only 20 to 50 kilometers thick. These finely detailed arches may be the elementary building blocks of solar flares. The discovery confirms long-held predictions. Theorists had speculated that flare loops could be tens of kilometers wide, but only now have we seen them directly. Each bright loop traces a magnetic field line, and Inouye's 24 kilometer resolution was critical to distinguish these strands. These loops store huge amounts of magnetic energy that suddenly release in a flare. Seeing the sun at such tiny scales matters. It refines our models of magnetic reconnection and solar storms that can trigger auroras and disrupt satellites. As one researcher said, this is a landmark moment in solar science. We're finally seeing the sun at the scales it really works on. Clues to Jupiter's birth lie hidden in meteorites. Tiny spherical raindrops of molten rock called chondrules have puzzled scientists for decades. A new study shows that early Jupiter's powerful gravity stirred up the asteroid belt. This caused high-speed collisions that flash-melted material into these glassy droplets. By matching computer models of Jupiter's rapid formation to the chemistry of the chondrules, researchers could timestamp Jupiter's growth. The results indicate that peak chondrule formation happened just 1.8 million years after the solar system formed. Essentially, this was the moment Jupiter reached full size. In other words, these cosmic birthday candles date Jupiter's birth to about 4.6 billion years ago. This provides one of the most precise clocks yet for the solar system's early days. Remarkably, a tiny mineral droplet on an Earth meteorite has become a clock for Jupiter's origin.